My name is Tom and I'm a software engineer here at Redux. Before we begin, let's quickly go over what exactly Redux is. Redux is a service that connects systems together and allows them to communicate healthcare data back and forth. Who are these systems we're connecting? It can really be anyone. Hospitals, clinics, huge health systems, software startups that are in their first week of existence, software companies that have been around forever. It doesn't really matter as long as they have an agreement to start exchanging data. But here's the thing about all these systems. They all have a different way of storing and sending this data. You see, the places providing patient care, hospitals, clinics, you name it, they each use software to store patient data. We call these electronic health records, or EHRs. You've probably heard of some of them like Epic or Cerner. Connecting and exchanging data with a Cerner installation is very different from connecting and exchanging data with an Epic installation. And since each of these healthcare organizations might have a customization on top of their individual installations, now exchanging data with one hospital using Epic might be different from exchanging data with another hospital using Epic. So if you're trying to build software that improves the healthcare industry, it's difficult because you run into this, the interoperability problem. There's no clear way of sending healthcare data from one place to another without rebuilding parts of your software every time you connect to a new system. Until now. You guessed it, Redux solves that problem. Redux will set up these connections for you and sit in the middle of the connection and provide a sort of translation service. So if a hospital wants to send you an HL7 feed of ADT messages, our system knows to standardize that to our patient admin data model before sending it along to you. And if you want to send a patient admin message back to the hospital, we'll translate it to that HL7 format that the hospital wants to receive. On your end, you can be sure that the format of the patient admin message you receive will be the same no matter who it's coming from. The beauty of the Redux API is that it allows you to build your software once and connect to as many systems as you please. Because building with the Redux API puts the job of understanding all those minor differences between systems on us, on Redux, and it allows you to focus on your product. So whether you're just starting out building your product, or you already have deals in place to start setting up integrations, the next step is to start building with the Redux API. So let's see how to do that with sample data using the Redux dev tools. For this example, we're going to start by listening for scheduling messages, specifically the new event type. These messages are often triggered when a new appointment is created in an EHR. Next, we're going to set up a way to query for a patient's clinical summary. The clinical summary that will be returned is essentially an overview of a patient's health, with information like allergies, medications, family history, a bunch of stuff. Finally, we'll set up a way to send new media messages. This is just an example, but your software might want to look at the clinical summary and based on the problems or diagnoses listed, create a PDF with a customized treatment plan for that patient, which you then send with a media message. That way, when the patient comes in for that appointment that was just scheduled, the doctor will see that there's a PDF attached to their file with your recommendations. Scheduling, clinical summary, media, these are just 3 of the many Redux data models. You can view them all in our developer docs. Once you've signed up for Redux on dashboard.reduxengine.com, you'll see your organization's homepage. But to start listening for those scheduling messages, the first thing we'll want to do is set up a new destination. Think of a destination as your application's endpoint, where data that originates from the system you're connected to gets sent. You might think of it as a webhook. So, to set up this endpoint, we'll need a server. I'm going to use a DigitalOcean virtual server, which I've configured to run Node.js. I'm also installing Git so I can sync files between my local computer and the server. Now, on my local computer, I'll create a new node project using the npm init command. I'll add express to handle routes, request to make HTTP calls, body parser so we can read the body of the post requests, and a package called lowdb, which gives us a simple JSON database. I'm going to add a gitignore file with the node modules folder, and the JSON file we'll use for lowdb. To verify that the server is working as expected, I'm going to create a simple route that returns hello world. I'm also adding a few lines that will start the server when we run the Node app. To sync these files with the server, I'm going to push them up to my repository on GitHub, then pull them down on the server. You can view all the sample code used in this video at the link shown here. Now that I've synced my files to the server, I'll run a quick npm install to make sure I have the packages available here as well. And now that that's finished, I'll run node index.js to start the server. If we open a web browser and navigate to our server's IP address, we'll see that it's returning hello world. Back to our local code editor to set up the code we need for our destination. The first step in creating a destination is to verify the endpoint. To do that, we have to listen for a GET request from Redux, make sure the verification token that Redux is sending in the headers of that request matches the verification token that we defined, and then return the challenge string that was sent. I'm going to define another route as well, this same route as before, but listening for post requests this time. This is where those scheduling messages will actually be sent. The scheduling message itself will be in the body of the request, so I'm just going to log the body and return. Now we can sync these files, start the node process again, head back to the Redux dashboard to verify our destination. First, we go to our destination that we created, click on the settings link, and enter our endpoint. In this case, it's our server's IP address with the destination route appended. You might enter a domain name here, such as yourapp.com, and the route can be whatever you want. It doesn't have to be /destination or anything like that. Now, for verification token, we'll enter the string that we defined in the code that we're checking against. For this one, I'm just using ABCD1234. Doing this check just lets your server know that the request is coming from Redux. Okay, we'll click Save and Verify, and if our code works, it'll send back whatever challenge value Redux sent along, and we're verified. Excellent. Now we can start sending sample scheduling messages to our destination that we just set up. To do that, we hop over to DevTools, and remember, we're still in our destinations page on the dashboard here, and select the scheduling data model, the new event type, pick some examples from the dropdowns, and the DevTools here generates a sample of what will be sent to your destination. So now if we hit Send Data Model and look back at our server, we'll see that we received this big JSON object from Redux, and that's the scheduling message. So now that we have our destination and can receive data from Redux, let's do something very simple with that data. There's a lot of data in our data models, as you can see, so let's just pull out a few fields here that we want to store. If we look at our developer docs over here at developer.reduxengine.com, we can view a specification for all the data we might expect in the scheduling message. For today, let's just store patient name found in patient.demographics, some visit fields, and some visit.attending provider fields. We'll also store the entire patient.identifiers array. We'll need that later. Okay, so let's add a check to make sure this only happens when we receive a scheduling new message, and we'll use that loadb to store the info we want to keep in a simple database. Just setting up the database here. Have it use a file called db.json and write it to the appointments array. Great. I'm going to add one more route here, get/appointments, and have it return all the appointments we have in our database. Okay, let's sync this again, start our server, and send another scheduling message. If we go back to our server and take a look at db.json, we'll see that we've now stored that new appointment. And if we go to the web browser and look at /appointments, we see that the appointment is getting returned. Awesome. One last thing to look at here is the logs. For data sent to a destination, we call this the transmissions page. And if you go to that transmissions page for your destination, you'll see records of those scheduling messages you generated from DevTools. And you can click on their IDs to dig in and see some troubleshooting information. So we've now set up a simple destination. Let's move on to setting up a source. A source is the other side of a connection. It's where messages originate. For our destination that we just set up, an EHR that is creating an appointment might be the source. But what if we want to send data back into the system we're connected to? Well, now we have to become the source. With a source, you can also perform some queries, such as patient search and patient query for clinical summary. I'm going to show you an example of that clinical summary patient query in a minute, but you can read more about all of these on our developer docs. Let's create a source in the dashboard. Now, if we navigate to DevTools for the source, you'll see two tabs. One generates sample curl commands, and the other is a Postman collection that you can download and test out with Postman. We'll stick to the curl command tab for now. You can see here that step 1 is to authenticate your source. And to do this, we need our source secret, which we'll have to set up in the settings page first. So if we go to our settings and scroll down to the Redux API section, we can generate a new source secret, copy that value, go back to DevTools and paste it into the text box there. Now if we run that curl command in our terminal, we'll generate an access token. As you can see here, we got an object returned with access token, expires, and refresh token. Copy the access token part of that, since it's what we need to send messages, and go back to the dashboard and paste it into step 2. This will generate a sample curl command for sending messages. We're going to set up a clinical summary patient query first, so let's choose that. So this here shows the request we need our code to send in order to get a patient's clinical summary. But obviously our code needs to get an access token first, so let's take care of that. Back in our code, we're going to set that source secret as one of our variables and our source API key as another. Now we'll make a function called getAuthToken that will call before each request. Since the access token is good until it expires, we don't need to make unnecessary calls to retrieve new tokens. That'll just slow things down. So we'll store it to a variable in our process and only request a new access token when it's needed. Normally you'd want to use that refresh token, but we'll skip that for now. You can read about it in our developer docs. So as you can see, if we already have a valid token, we'll return it in the callback function. Otherwise, we'll request a new one, update those variables, and return it with the callback. Now we'll set up the function that performs the clinical summary patient query. We'll create a function that takes the appointment object, call our getAuthToken, and then set up a request like we saw in DevTools. So we set our URL to the query URL. It's a post and it's JSON. And the authorization header is bearer space and then our token. Now we'll set the body to have the proper meta object. This is a test message and we're using the default destination. And for clinical summary patient query, the only other required field for the request is the patient identifiers. So we'll put those in. Now we'll make the request, log any errors, log the response code Redux returns, and log the body, which should be the clinical summary. Now let's modify our destination code to call this function when we receive a new scheduling data model. And we can sync our code back to the server again, start our application, and go back and send another scheduling message from the destination DevTools. Now back on our server, we can see that we received the scheduling message, we got a new auth token, and we successfully got the patient's clinical summary. Now as our final example, let's send a new media message back after we've got that clinical summary. Normally you would generate a media file like a JPEG or PDF and then send it, but we'll just send a blank one to keep this simple. Back in our code, we'll create a new function to send a media message. Following a similar structure from before, we'll get an auth token, then set up our request. Since this isn't a query, we'll use the endpoint URL, set our headers just as we did before with the token, and now taking a look at DevTools, we can generate a sample request. So we'll take the body of that message from there. But we will use those patient identifiers from the original scheduling message and the provider ID as well. So now we've set up our request. Once again, we'll log any errors, the response, and the body. Make sure we call this after the clinical summary has been retrieved, make the logging of the clinical summary a little shorter, and now we can sync our code to the server once more. Okay, one more time we'll start this process off by going back to our destination's DevTools, sending a new scheduling message, and as you can see here, we received the scheduling message, got a new auth token since we restarted our server process, got the clinical summary, and tried to create a new media message, but it looks like we got an error. So let's go to our logs for our source and check it out. This page is called Messages. As you can see, we have a message here that has an error, so we'll click on that to open it up, and we can see that we're missing the required field patient.identifiers. Looking at the code, it looks like I set up the patient object to just be the identifiers. I forgot to nest that property, so we'll fix that. Sync the code once again, start the app, send that scheduling new message from the destination DevTools, and looks like this time there was no error. So if we refresh that logs page, we can see the successful media message here as well. So that's a quick example of how you might get up and running with the Redux API. I hope you found this helpful. I recommend taking a look at our developer docs for more in-depth guidance on everything I covered here, and when you're ready to start setting up connections, get in touch with us. If you have any questions, of course, you can reach out to us as well. The easiest way to do that is using the little circle icon that appears in the bottom right corner of all of our websites, where you can start a chat with one of our team members. You can also join our Slack community, which is where we have over 1,000 members chatting about developing software for healthcare. Thanks so much for watching this demo, and I hope you enjoy using Redux.